Thank you very much. So before lunch, I promise you no difficult sums in this talk, just some very pretty fossils, I hope. I want to introduce a Lagerstätte that we've been working on for a short time and now have some reasonably decent funding and some hope then to advance the study of the fossils considerably. It's an unusual case because the fossils have been known since about 1850, but oddly enough have never been adequately studied. They were found by this distinguished and quite well-known geologist from Victorian times, Charles Moore, who's associated with Bath, and he made very large collections, particularly in the Triassic and Jurassic of the southwest of England. And his collections started at Ilminster, where he was born. And he tells the story that he found the site because he saw some schoolboys kicking a nodule around in the way that schoolboys do, and he must have bought it off them for sixpence, or maybe clipped them round the ear and took it off them, broke it open, and inside was a beautiful fish fossil. So that was the start of the story. But famously, some of you may know the story, he collected vast amounts of stuff, and it was all displayed in a museum in Bath, and then sadly after his death, the collection was rather forgotten. And it only came back to life in a way about 10 years ago. Several times during the 20th century, this collection could have been dispersed and lost. This is often a story of these kinds of private museums that go into municipal ownership. This is what it looked like, the various boxes and so on that had not been opened since Moore had died in 1881. And together with Matt Williams, who's been curator at that museum now for over 10 years, we got some funding initially from the Esme Fairbairn Foundation, which is a very useful source of funding for museum development. And that paid Matt Williams to unpack and discover and catalogue and restore these collections. And then subsequently we have secured funding from the Leverhulme Trust, and I'll talk about that in a second. But the Esme Fairbairn money also paid for a great deal of development of the fossils, conservation and preparation. Laurie Barber was employed to do this, and there are a few before and after images there, above and below, showing what she was able to do in terms of physical preparation. Because, of course, this kind of outcome is not what Moore could do. He, like many other Victorians, used a hammer and chisel, and that was a rather rough and ready way of getting at the fossils. Here in the ventral view of this Pachycormus, you can see all the fine detail of the branchiostegal bones. And in this case, a before and after, above and below, of a small crocodile skull. And again, Laurie was able to extract a great deal of information. A considerable amount is known about the site of Strawberry Bank. This lovely name comes from a part of Ilminster, which this is the traditional name of the site. But soon after Moore had cleared out the fossils by about 1850 or 1860, it was built over. And Matt Williams has been there, I've been there, we've made inquiries, he's knocked on doors. No, he can't demolish the houses and dig out the site, unfortunately. But we're trying to find neighbouring locations which may be of the same age. Fortunately, though, and this is a message to all of us, Charles Moore was a very good recorder of information. And so this is his sedimentary log recording every bed and the fossils within them. And so there's enough information here to tie with the fossil collections that still exist. And many layers there indicated with invertebrates, including ammonites, so it's possible to match this to a modern stratigraphy. And to understand the exact age, he got it right, he marked it as the equivalent of what would now in certain parts of the world be called the Falciferous zone. And so this is early Toarcian, and it's equivalent in age to exactly the peak of anoxia at the height of the Toarcian oceanic anoxic event. We published a summary review of the background story and presented the fossils and the locality in a short paper published recently in the Journal of the Geological Society. And now we have funding from the Leverhulme Trust that will pay for Benjamin Moon, who's here, and he will be a postdoc working mainly on the ichthyosaurs and other marine reptiles. And there will also be a PhD student beginning with Matt Friedman in Oxford, we hope, next September, mainly to work on the Pachycormid. So amongst the fossils, there's that collection of some 800 insect specimens. They were not found in the nodules, but in the bedded sediments around the nodule layers. And with the eagle eye of the eagle eye of Andrew Ross, he was able to identify many of these, and there's a summary there of some of the fossils, and you can see examples with some original color patterning on the wings, and in many cases enough detail of shape and venation that they can be identified to a certain extent. So the rich fauna of insects associated with the marine fossils is an interesting combination. The vertebrates are probably the most spectacular fossils. There's a summary of the numbers of specimens. And these include a variety of fishes, some smaller forms indicated there. But most importantly, Pachycormus, which is represented by 100 specimens. You saw some pictures in the last lecture of later pachycorniforms of the Jurassic, which became very large, like Leedsichthys. They were planktivores. Here's one of the earliest pachycormids, then from the lower Jurassic of Somerset. And these things are up to about 80 centimeters or a meter in length. They're three-dimensional because they're contained within nodules. And the hope is then to scan all of these to get a great deal of three-dimensional detail from them and internal anatomy. There is a certain amount of high-quality preservation, some exceptional preservation, but not as much as we had hoped. But nonetheless, the high-quality preservation allows us to see great detail of the scalation and the fins. Here's the small crocodile, Pelagosaurus. Notice it really is very small, so this thing, you could hold it on your hand. And all of them are rather smaller than might be expected from this collection. Stephanie Pierce described these as part of her PhD a number of years ago, and these were published with some wonderful drawings by John Sibbick. Here's the reconstruction of the skull, so very delicate, very beautiful specimens. And at the time, we did scan one of them, but that has not yet been published, and at that time, scanning was a little harder than it is now. And the reconstruction of this little crocodile with some of the smaller fishes round about. There are also ichthyosaurs, 2 species, and these were studied by a master's student, Hannah Kane, in Bristol, and the initial publication already presents the specimens without scan data. And so she was able to classify these, but again, like the crocodiles, these are smaller than expected. They're very comparable. There's plenty of comparative material in the Toarcian of Whitby in the north of England and in France, and particularly in Germany. These ones are always smaller, it seems. And some of the fossils are quite unusual in that there are seemingly uncrushed eyeballs with the entire sclerotic ring. Not only the part that you normally see when you look in the eyeball on the lateral view of the skull, but also wrapping around, so they go all round the eyeball. And so that will be fascinating to scan those and see how that system of very thin plates holds together around the orbit. Again, these are juvenile. If you know your ichthyosaurs, you'll recognize that this skull shows juvenile features in, for example, the relatively enormous size of the orbit. So we've suggested perhaps there are no larger reptiles. It could be a taphonomic artifact, that somehow larger creatures are not being preserved within the nodules. But we think it's more likely that this is truly what the size range is, and that associated with the fishes living in shallow water, indication of near coastal location because of the relative abundance of insects, that this could have been some sort of protective nursery for these small reptiles, which would later go offshore and grow to 2 or 3 times the size that we're finding. As an experiment, we have scanned one of the crocodiles, but we've also scanned one of the ichthyosaur skulls, and that turned out to be very rewarding. The scan takes a long time, but nonetheless, the detail is there. And so Ryan Marrick, who is a master's student in Bristol, was able to generate this reconstruction, which was published earlier in the year, and showed certain detail of ichthyosaurs. You see, if you think we know everything about the anatomy of ichthyosaurs because of exceptionally preserved specimens from Lagerstätte in Germany, like Holzmaden, or from Lyme Regis, they may look beautiful, but they're as flat as a pancake. So you need this kind of 3-dimensional preservation to get the detail of the palate and the occiput and the brain case and so on. So for example, here Ryan was able to reconstruct for the first time a 3-dimensional brain. It's a little bit incomplete underneath, but it gave enough detail that he was able to identify A, that they're not entirely intelligent creatures, and B, he could identify the different sensory zones of the brain, as shown there. There is some exceptional preservation, as I said before, not as much as we had hoped, but some of the fine detail of bones that are not normally preserved in the fishes. There's a stomach trace there, there's some hints of skin, perhaps in C and D, and there are teuthoid cephalopods with ink sacs and some other structures that Jakob is going to work on as well, but not as great an array of exceptional preservation as we had hoped. So the overall reconstruction shows something, maybe that's a little bit too inshore, but there we are with insects flying out. There are bits of wood here and there confirming that it's reasonably close to shore. And the large pachycormiform, not yet a planktivore, presumably feeding in different ways at that time. The combination of marine fossils and insects is not unusual. There are a number of other locations, particularly in Germany, of exactly the same age. So bear in mind that age is Falciferum zone, early Toarcian, marking the peak of anoxia within the Toarcian oceanic anoxic event. And there are a number of sites of exceptional preservation across Europe, in the UK, in France, and famously, of course, in Germany, Holzmaden being the most famous. And the proportions of fishes and reptiles in the top row and insects in the bottom row are rather different. So, for example, with the insects, in orange are the beetles, and the Strawberry Bank fauna is dominated by beetles, which may be a taphonomic artifact, but a student in Bristol, Richard Kelly, will be taking that study forward, working with Andrew Ross to try and work through all of those insects and present those properly. We're on tenterhooks, the Bristol crowd, because our scanner arrives this Friday. Here it is. We hope it looks as beautiful as that when it is battled into the building and plugged in. And so we're going to start one of the early projects once this thing is fired up in January, will be to try and scan everything from Strawberry Bank and try to expose as much of the three-dimensional detail as we possibly can. So I'd like to conclude by saying it's a privilege to have this opportunity. Most Lagerstätten in Europe have already been studied. Because of the vicissitudes of the history of this case, we have access to it, and almost nothing had been published up to now. So I'm looking forward to seeing what we can discover and whether there is something interesting in this apparent coincidence in age of maximum anoxia and rather frequent occurrence of Lagerstätten across Europe. Thank you for your attention.